In this video, let's have a look at Heron's formula, and that's a specific formula that you can use to find the area of a triangle, and its particular use allows us to find the area of a triangle when we have only the length of 3 sides, no angles required. In the previous video that I did on area of a triangle using a sine rule, that was 2 sides and an included angle. But if you don't have that and you only have 3 sides, then there's this formula here. So labelling the sides A, B and C, those little letters that we're used to, and the steps involved in finding that for Heron's rule, 2 steps. There's something called a semi-perimeter. So the perimeter of a shape, as we know, is the distance all the way around the outside. So you find that, so you add them all up and divide that whole thing by 2, and that's called a semi-perimeter, or like a half perimeter. Just be careful when you're typing things like that into your calculator. You might need to push the fraction button first to get that happening, or put the A, B and C in brackets, because otherwise if you do 3 numbers in your calculator, A plus B plus C, and then divide 2, it's actually only dividing the C by 2, so just be careful with the way you type that in. And then you use that information to find the area, and here's the formula for that. So the area of this triangle with only 3 sides, it's the square root of all of this. So look at how the S appears 4 times, and 3 of those times it's paired with each of the sides. So it's S on its own, then S subtract A, S subtract B, S subtract C, and all of those things are multiplied together. Let's put that into practice with an example. Finding the area of a triangle here, we'll do a 3, 4, 5 triangle. So the steps to do here, let's find the semi-perimeter to start with. I would encourage you to write out the formula so that you're familiar with what you're trying to do. So the semi-perimeter is A plus B plus C all divided by 2. Let's substitute those values in. It doesn't matter which one's A, B and C. You possibly don't even need to label them, but it could be good practice. 3 plus 4 plus 5 all divided by 2. What's that? 3 plus 4 is 7. 7 plus 5 is 12. 12 divided by 2. So our semi-perimeter is 6. And now we're going to use that 6 in the next step, finding the area. Let's write out the formula for that. Area is equal to the square root of, I'm going to leave the top bar line until I've done it all so I know how far to draw that bar. S on its own, then S subtract A, one of the sides. S subtract B, and then S subtract C, and that's the square root of all of that. So then we substitute our values in. Area is equal to, the semi-perimeter we've found is 6, and then each time around we're going to do 6 subtract each of the sides. Do you notice that the number 6, that semi-perimeter, is greater than the length of any individual side? So therefore, if you get a semi-perimeter and your number that you've got for that is smaller than one of the sides, you've probably made a mistake somewhere in here. Calculating that all into your calculator, we would get the square root of 36, which comes out neatly to be 6. So the area of this triangle, it hasn't given us units, but it'll be 6 units squared then, or it could be centimetres squared, or whatever. So writing out the formula each time for your semi-perimeter and your area, and then substituting in your values. There's the questions that match this section now. Give a thumbs up and a subscribe to the channel. Thank you.